All right, we're gonna go through theoretical probability. This is gonna feel pretty simple, but we need to review like sample space. What is it asking for? So let's take a look. Find the sample spaces and theoretical probabilities of each scenario. We will assume each role is independent of each other. So independent, it's important to know what that means here. Independent means that each role does not affect the next role, okay? And that the dice are fair dice. So none of them are loaded. If we're looking at a four-sided die, then the sample space would be a 1, 2, 3, or 4. Um, it's kind of tricky, like if they say how many outcomes, there are 4 different outcomes. But if they ask for the sample space, then they're actually asking you to list every possible outcome. Okay? So 1, 2, 3, 4. Now, this would mean the probability of rolling a 1. So that means that you want the outcome to be a 1. Well, we have 4 different options. 1 is only one of the outcomes, and it happens 1 time out of 4 times. So the probability would be 1 out of 4. Okay, the probability of rolling a 2, you can't just say 1. Like, yes, there's one outcome that is a 2, but the probability means that it's asking for the percent chance that it happens, or you could write that as a decimal, or you could write it as a fraction. So if I say 1, that's not telling me. That would be like 100%. This is actually a 1 out of 4 chance. So that's how you have to write probability. You just can't count it up and put the number down. You have to have it out of the total outcomes. So that would be a 0.25 or a 25% chance. So probability can be written in those 3 different ways. Okay, so probability that you roll a 3, that's a 1 in 4 chance, and same thing for a 4. Okay? The next one, if we look at a 12-sided die, that means that our sample space would be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that would be our sample space there. Now, the probability of getting at least a 4, that would mean 4 or greater. So at least a 4, that means 4 is a winner or anything bigger than 4. So you would look at that here, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means we have a 9 out of 12 chance, okay? We could reduce that, we could write it as a fraction or as a decimal, as a percent, but this is showing us exactly how many out of the total. So I'm okay with that. All right, how about greater than a 4? Sounds kind of the same, but greater than a 4 does not include 4. That means 4 doesn't work, so we would only be looking at 5 to 12, and so that would be 8 out of 12, okay? They could ask you the probability of getting something between 2 and 6 inclusive. So the inclusive means that you are including the numbers 2 and 6. So that would be this section. So between 2 and 6 would really only be 3, 4, 5. But if they say inclusive, then that means including 2 and 6. All right, so 1, 2, 3, 4, 5. That would be a 5 out of 12 chance. Okay? All right. The next one gets set up a little differently because if you're rolling a 6 and a 4-sided die, and we are adding the faces together, we are supposed to find the sum of the faces. That means that our sample space is a combination of the 4-sided die mixed with the 6-sided die. All right? A lot of times you put up here if you're adding it or subtracting it or whatever the case might be. So this means that we need to set up the sample space of what could happen if you roll a 1 and a 1. That means that you could get a 2. So notice 1 is not in the sample space. These numbers do not count in the sample space. You can't roll a 1. You can't get a 1 when you're adding up 2 dice because the 1 plus the 1 is a 2. That's the lowest number you can get. Okay? Likewise, the highest number that you could get would be the 10, the 4 plus the 6. So when you fill this out, your sample space here would be everything from 2 to 10, right? So that's your possible outcomes. But that doesn't just say how many, all right? So your possible outcomes would be 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you wanted to know how many possibilities there are, you would have to fill out the table. So this would be a 2 plus a 1, a 3 plus a 1, a 4 plus a 1, okay? And then we keep going. 3, 4, 5, 6. So we're doing 3 plus 1, which is 4, 3 plus 2, which is 5. You guys see what's going on here? And then this would be 5, 6, 7, 8. And then lastly, oh, no, I'm squeezing this together here. This would be 6, 7, 8, 9. And then we would have a 7, 8, 9, and 10. So if we look at this and we know that there's 4 choices here and 6 choices here, that means that there are 24 outcomes. Okay, so it's out of a total of 24. Now, the sample space would be 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? All right, so the probability of getting a 5, it's really nice to have this written out here so that you can look at it and just say, how many 5s are there? 1, 2, 3, 4. So there are 4 outcomes out of 24 possible of getting a 5. Okay? All right, probability of the 7s, that would also be 4 out of 24. Probability of 10, that's only 1 out of 24. Okay? At most, a 9. So at most 9, that would be everything except the 10. So that looks like a 23 out of 24. Everything less than 8, so you're counting all of these. 1, 2, 4, 5, 6, 7. Okay? We have 18 out of 24. The probability of getting a 5.5. Well, if you're adding up 2 dice, that's not going to happen. So that's actually a 0 out of 24. How about greater than 5.5? Well, we can do that because that would be all the 6s, the 7s, the 8s, 9s, and the 10s. So we have 4, 8, 9, 10, 11, 12, 13, 14 out of 24. Okay? Now, like I said, we could absolutely turn all of these into decimals or fractions. So 1 out of 24, this would be a 0.04, which would be a 4%. Okay? So like the 4 out of 24 here, this would be 0.17, and that would be 17%. Okay, so your probabilities could be written in any of those ways. I'm going to scroll this down so that you can take a look at this one. This one is a 4-sided and an 8-sided, and it is the product. So we multiplied these, okay, and filled this out. That's your sample space there, and that's how many outcomes. And you can look to see how the probabilities are chosen. All right, so that's our first start here for the probabilities. We'll do some more on the next time.